Welcome back to CRG. This week we're going to continue looking at this Philips Videopac G7000 and let's see if we can't get that video fixed. It does make sounds, as we figured out last time. Still no video though out of this PAL encoder, so let's take a closer look. Just before we start poking around the board, trying to figure out why it doesn't work, let me show you something from the service manual. So this is the manual here we were referring to last time. If we go down to page 4, this lists out various signals that we should be able to see on the scope. So for example, pin 12 of IC661, we should see this here, 17.734 megahertz signal. One problem I've been having though is that this service manual isn't directly related to my revision of board. On my board, all the ICs are numbered differently. I have been able to find this service manual as well, and this one is directly related to my board. It doesn't have this list on it, and unfortunately, as you can see, the quality of this is rather poor. In particular, when we get down into the schematics, you can't really make out what's going on. But between the two of these, I reckon I've been able to cobble together this page here. So that's just this over here. And I have relabeled everything to the corresponding ICs on my board. And to be honest with you, I think it falls at the first hurdle. Pin 12 of IC9 does not have this signal on it. So this is IC9 here, and if we just turn the power on and then take a look at what's happening on pin 12, so 14, 13, 12, you can see there that the image from the scope bears absolutely no resemblance to what is listed in the service manual. While poking around the board, one thing I thought interesting though is this. This capacitor here is labelled R3. And if we just take a look at those rather poor schematics, you can see that R3 here is shown as a resistor, as you would expect, R after all, and not a capacitor. And it looks like it should be a 470. It's really hard to make it out on this. R4 looks like it should be 510, and testing R4 here, it does read around 500 ohms. So I think that says 470. One thing though to note, there is a lot of dodgy solder work on this board, as you know, but at this point here, that looks like it's always been there from the factory. That is that point there. It doesn't look like any reworking's ever been done. So either what we have here is a further revision away from those schematics, or that is possibly the wrong component in there. Either way though, that capacitor seems to be shorted, because we have the multimeter out here in continuity. And there seems to be a dead short through that. So we're going to remove that from the circuit and test it again, see if it is shorted. I am tempted to fit a 470 ohm resistor in here, just to see what happens. And the other thing I want to do is remove these two transistors, test those as well out of circuit, just to make sure they are okay. And yeah, hopefully it's either those, or I'm leaning towards this. Let's get those removed and let's give them a test. So let's just see if this actually is shorted or not. Meters on continuity. No, it's not. Now that's interesting, because why were we reading a short across it? So it seems I was maybe being a bit thick. Of course we were reading a short through this capacitor here because it sits in parallel with this inductor, and an inductor will read as a short through a multimeter. Well, near enough short anyway. We were reading what, 0.7 ohms or something like that. So I tested an inductor on one of my Commodore 64 boards as well, and it reads sort of similar, about 0.7, 0.8 ohms. And after a quick bit of googling, it shouldn't be a dead short, but it should be between 1 and 11 ohms according to that. We're sitting just slightly under 1. I dare say this is actually fine. I also tried fitting a 470 ohm resistor in here instead of our little capacitor, and it didn't make a button of difference. The system does work, it still powers on, we get our sound and whatnot. Still no video generated, and those signals from IC9 still look the same on the scope. There's the two old transistors out of the board. Fitted two new ones here, but it's just working exactly the same way. System still powers up, still makes its wee jingle, but the clock signal up on IC9 here just looks identical still. I'm actually starting to wonder, is it just this PAL encoder that's bad? It's just not generating a composite signal. I actually don't think there is anything bad down here. What am I going to do though? Because I can't let it beat me, yet I'm running out of ideas. Let's build an RGB mod, and let's just take our video signal direct off this video processor. Surely that has to work.
I'm doing everything I can. And stop calling me Shirley.
So I'm going to be following this schematic here for the RGB mod. I'll stick a link to this down in the video description. And I'm just going to build it on a bit of this perf board using some of those. And through the magic of video editing, here's one I made earlier. What an absolute mess of wires. But we will tidy it all up when we're putting it into the machine. Probably could have made this a bit smaller as well, but it is what it is, it's done now. So, to connect this up, what I thought I'd do is just remove this PAL encoder, because after all, I'm fairly sure this is what's faulty. I want to remove that, and then we can just make off the wires into the holes that are left behind. All the signals we need come direct from this video processor here, direct across to here. So I think that will be the easiest thing to do. So we're down the TV end of the cave here, and everything is hooked up, albeit rather sketchy at the minute. Hopefully this works, then we can put it all in the case and tidy all this up, make it look like something, but I want to test it first. So we're connected up via RGB SCART to my SCART to HDMI converter, then to the TV. Let's see what's going to happen. We get sound. And yes, it looks like we're getting a picture, and that looks really clean, doesn't it? Very sharp image on select game. Let's get all this back in the case, and then we can try playing a couple of games. So I've removed the RF modulator, and this is our RGB board, just held in place with some of that double-sided sticky tape. It is well and truly down there, not going anywhere. Now it's just a case of routing all these wires neatly, hook it all up again, and we're done. So a lot of the faffing about I was doing at the start of this video with the scope I have since discovered is probably a bit of a waste of time, and those waveforms that didn't look right on the scope has nothing to do with this machine, but rather my probe, this thing here, that is just not sensitive enough to read those waveforms properly. And I am pretty confident now that the fault with this machine has been that PAL encoder all along. It has something wrong with it. Now you could probably wire up a modern PAL encoder to this, to generate that composite signal that the RF modulator is looking for, but what's the point really when you can do this RGB mode? Because this is always going to give you a better video signal. So I unfortunately lost an auction tonight for another one of these machines. Not that I really want another one, but it was more that it had 5 games with it, and one of the cartridges was the programming one, which would have been pretty cool to have. Just missed out on it. Oh well. I'll keep an eye out to see if I can't get a programming cartridge somewhere, because I honestly think that's the only way we're going to be able to test this keyboard properly. I'll tidy all these up in a minute, just with a bit of PVC tape or maybe a wee cable tie or something, just to sort of hold them in shape. But the next big decision we have to make is where are we going to mount this, our output jack for the RGB signal. Everything is connected to the top of the machine, so ideally you would want to mount this on the top of the machine as well, but there isn't really anywhere handy to do it. I could mount it sort of about there, but that's going to be about there, and it's very high on the machine. So what I'm thinking of doing is mounting this to the bottom. Now I know that will permanently attach the top to the bottom. There's nothing we can really do about that. But if I leave enough length on those wires, it should be a case of you can open it sort of like that, if you know what I mean. I think that's pretty much the best we're going to be able to do. I don't really want this poking up at the top, it's just going to look stupid. So I need to cut a hole. Just think about this. That goes on like that. So I need to cut a hole in the case about here somewhere, I would say. Sort of about here. So I have that port mounted in there now, nice and secure. And that's what I was talking about. So when it's open, the base would sit beside the top like this. So what I need to do is run these wires across with enough length that they can comfortably open like this. So what I'd probably do is bunch the wires, just something like that, and then just run them up there and leave all that length on them, just so that we can open the lid without straining these wires. Ideally we would have some sort of pin header on here that we could disconnect, so that you can disconnect that, and I may look at that again in the future at some point. I may try and rebuild this board, make it a bit neater, but for now anyway, that's all we're going to do. So that's everything wired up as I said, and this wire is long enough now that we can comfortably close the lid, then open it again whenever we need to work on this board. So let's just close it up. Put these screws in, and then that is our little Videopac G7000 finished. There's our new port on the back. Let's take it down to the TV and try out those games. Okay, everything's plugged in, ready to go. Let's start with game number 6. What was this one again? 10-pin bowling and basketball. So how do we select a game? One. How many players? Just one. 10-pin bowling. So close to a strike right off the bat. Let's go. Oh yes. And a spur. Player 15. Oh here. What? The ball ran over those. Oh, that's my score. Right. A 7-10. Gonna be able to do anything here? I don't think so. And I completely missed. Fun wee game. It's a bit basic, but I have to say I'm very impressed with how the quality of this looks. It's just so clear. See if we can get a strike. No. Right, here we go. Let's try and get a strike this time. And then we'll try something different. Oh, so close again. Wasn't to be. Right, how do we get into the basketball then? Number 2 maybe? Nope. There we are. Detailed animation. Oh yes. Oh no! Rejected. Last minute. Let's go. So this is obviously meant to be a 2-player game. I tell you what, for looking so basic, I can actually see this being quite fun. Ah, come on. Get in there. Come on. There's 1 point. Let's try the other joypad or joystick. Yeah, this one actually feels a wee bit easier to use. This is the one that doesn't have as much wear. Almost an own goal there. Could you call that an own goal? And another one. I think this is going to definitely have to feature heavily in the next games night. Because this is so much fun. Nothing but net. Right, anyway. One feature of this machine is that you're supposed to be able to swap cartridges without having to turn it off. This is number 8. Baseball. Not very good at baseball. So what are our controls? So there's our bat on player 1. How do we pitch? Player 2, I assume. There we go. Oh yes, knocked it out of the park. And the crowd goes wild. Home run. Strike 1. But how do you go on? So you can move these field players around. That's not working. Oh no, you have to throw it, so you just can't. Is that him out there? Is much confused. I don't really know the rules of baseball. Anyway, yeah, don't really know what I'm doing there, but at least the game works. Right, let's try the last one, shall we? Number 39. This is Freedom Fighters. The little spacey one, and dead straight away. After a good start as usual. So we can control our little ship and we can fire, and dead again. Goodness sake, come on. Oh, we can turn around. Cool. The wee joystick does work okay, it's just not very sensitive. The movement is at the extremes of the throw of the joystick. So maybe it would be worth taking this apart at some point and just trying to give everything a good clean inside. Probably find a lot of carbon built up on the little pads in here. And a good clean might sort out its sensitivity a wee bit. And I did check, by the way, you can't just plug an Atari joystick into this, they are not pin compatible. Albeit you can build a little adapter very easily to do it. So that might be worth doing if we can't get these joysticks any better. I got my ass kicked here, haven't I? Well, anyway, that's pretty much it for today. I'm pretty pleased with what we've managed to achieve here with this little machine. It's a bit of a shame I couldn't get it working over composite, this native RF, but I think in the long run this RGB mod is definitely the better option. Graphics are nice and crisp and clear, nice and chunky. I'm pretty much convinced that the fault with this machine then was with that PAL encoder. Nothing to do with the rest of it. But we're there now. That's it. Thanks very much for watching. If you enjoyed this video, I would appreciate a thumbs up as it does help the channel. And I'll see you next time.